Ladies and gentlemen, today we embark on a journey of discovery and innovation as we introduce you to a groundbreaking concept that has just emerged in the world of computing. It's the year 1960s and the remarkable discovery of decision trees is just taking scientific community by storm. Lou Bremen, Charles Stone, and Richard Dijkstra unveiled the revolutionary concept of decision trees. Imagine a world where machines possess the ability to make decisions and choices like humans. Decision trees, represented by branching structures, provide systematic approach to decision-making based on data and logical reasoning. By asking a series of questions and making choices, decision trees can predict outcomes and classify information. It holds tremendous potential for implementation in diverse areas, such as finance, healthcare, and marketing. It can also guide doctors in diagnosing illnesses, or even help us in making choices in our daily lives. Together, let's witness the transformative power of data-driven decision-making, shaping a world where intelligent machines enhance our lives. Greetings everyone, and welcome to my channel. In this video, we are going to talk about decision trees. Decision tree is a supervised machine learning algorithm used for classification and regression tasks. It models decisions or decisions based on features or attributes of the input data. It is represented as a flowchart-like structure, where internal nodes represent the feature tests, branches represent possible outcomes, and leaf nodes represent the final decision or prediction. For example, in the context of online content recommendation systems, companies like Google utilize decision tree-based algorithms to personalize content recommendations for users based on their browsing behavior and preferences. Google tests if the user has recently searched for technology news. When it's true, then previously clicked for AI articles. When it's false, are there other content? Clicked on technology-related articles, for example. If it's true, then recommend technology news articles. When it's false, then generic content recommendation. This decision tree takes into account the user's search history and past clicks to recommend personalized content. By analyzing user behavior patterns, the algorithm can identify relevant topics of interest and make recommendations accordingly. Decision trees, when combined with other techniques like ensemble methods, for example random forests or gradient boosting, can provide powerful recommendation systems that enhance user experience by delivering relevant and personalized content suggestions. Now let's dive into Python to implement decision trees. Firstly, we import our libraries. Then we load the datasets. The areas dataset contains measurements of different areas flower species. The variable x is assigned the input features, also called predictors or independent variables, from the areas dataset. These features include the sepal length, sepal width, petal length, and petal width. The variable y is assigned the target variable, also known as response or dependent variable, from the areas dataset. It represents the class labels of the areas flower species. The variable feature name is assigned the names of the input features, which are the sepal length, sepal width, petal length, and petal width. And now we create a decision tree classifier. Now an instance of DecisionTree classifier is created. This class is provided by scikit-learn and represents the DecisionTree classifier algorithm. Then we train the DecisionTree model on the iris dataset. The DecisionTree classifier is fitted to the input features X and the corresponding target labels Y. And now we visualize the decision tree. By tree plot tree, we visualize the decision tree. It takes the fitted decision tree classifier CLS as input, along with the feature names, class names. Then by field true argument, we display the plot with filled colors. And here we have it, the decision trees. As here we can see, the number of samples is 150 for the petal width less than 0.8 centimeters, and the class is setosa. And then it's divided into two nodes. Here its number of samples equal 50, the class setosa, but the gene is 0. On the other hand, here, the petal width is less than or equal 1.75, and the number of samples is 100 for the class versicolor. And then it's divided into two nodes for petal length less than 4.95 or petal length less than or equal 4.85. Here the number of samples is 46, but here is 54. Here is versicolor class and here Virginica. Overall, this code loads the iris dataset, trains a decision tree classifier on the data, and visualizes the resulting decision tree using matplotlib. The decision tree helps classify flowers into their respective species based on their measurements. Thanks for watching. I hope you enjoyed the video. If yes, then please don't forget to subscribe to our channel, hit the like button, share the video, and leave your comment under the comment section. Until next time, happy analyzing.